Hi everyone, my name is Anand and I hope you're enjoying the course on Python, right? So until now, you have learned a couple of things. You've learned a variable, okay? We learned that, you can store uh, some data in a variable, all right? It could be an integer, it could be a float, it could be a string, it could be a Boolean value and so on and so forth, right? We learned how to compare two things, all right? Using operators. We also learn how you can implement a particular logic or how do you make a decision using if else structures. We also learned if in case if you want to repeat some task, all right, you can use loops. And then we saw some sort of collections which are built-in methods, functionalities which you can use to store the data and perform some task on it. All right. Now let's deep dive a little bit more into the collections. Okay. And we will see what data structures does Python provide us to basically work with the data. All right. Now I don't have to explain, that as a developer, you would be working with a lot of data. All right, and you would need some sort of method, some functionality which helps you store the data, access the data, maybe modify it or even remove it, right? I'll take a very simple example of my college days. All right, uh, for me, when I used to have just a couple of shirts, maybe two t-shirts or a pair of jeans, etc., the easiest way for me is that I used to put everything on my bed, all right, where I'm working on my study table, right? And then I have to sleep at night, I'll just shift them and lie down, right? That was my way of accessing my clothes much easily. Not perhaps the best way, but yeah, for works for a bachelor, right? uh, you may be better, you may be storing, you may be keeping your clothes in a cupboard. Now there also you can do a lot of interesting things, right? You can sequentially place all your clothes, all right, in hangers with a specific methodology, all right, that okay, first we start with t-shirts, then we start with some jeans and shirts, etc., etc., and so forth, right? And if, let's say, if you have to go on a vacation, you would just place clothes on a pile wherein you would ideally want to place the clothes that you would wear on day one on the top, right? Think of a queue, all right? If you've gone to watch a movie, you're standing in a queue, right? You will be accessing, essentially, the theater guys would be giving the ticket to the first come first serve, right? They will give them the ticket, and then essentially that person gets the ticket, gets out of the queue, and then second person would come into the picture, right? The common theme here is that we have a lot of elements, we have a lot of data points. If we think one cloth, okay, has a data, and all right, not just we would want to store it in a particular fashion, we should be able to access them, do some modification, perhaps remove it, etc., etc. And that's where the idea of structures comes into the picture, all right? In order to store the data and manipulate it, all right, we need different structures, all right? um, to start with, we will be working on creating a task management app, all right? Think of your usual day, okay? It's a Monday and you have to do a lot of tasks. Not a very heavy Monday, you just have 4 tasks to do. Still a lot. I have to complete a project report, I have to attend a meeting, I have to review the code. And most importantly, a feedback session with your manager. Imagine on Monday, right? Now, you have 4 tasks. It's easy. You can just create 4 variables, and I'm calling it task 1, task 2, task 3, task 4, etc., etc., and so forth, and just storing some strings in there, right? Life is easy. Okay. The same task management app now has to, store all the tasks that you have to do in a particular week, all right, or particular month or whatever. And imagine that it can scale up to 1,000 tasks, 100 tasks, 50 tasks, whatever, right? Now, technically, I can actually create some 100 variables, okay, store it in different variables as strings, right? Technically, there is no problem in this, right? But here are some interesting challenges. Imagine task 98, which you were earlier planning to do in a priority sequence of 100 task at position 98, now your boss comes to you and says that, hey, Anant, you have to do this on priority. All right. Now you would have to shift its priority to, let's say, task 2, task 3, whatever, right? But I have something already saved in the variable task 2, right? Should I remove it? Should I store it in some other variable, etc., etc.? You can imagine that the manipulation of the data, all right, can be very daunting, can be very crazy if you have to do a lot of tasks, right? Um, Another use case, let's say if I finish task 1 and task 2, okay, ideally the task 3, okay, which is now the new thing that I have to do, should be called as task 1. All right, so task 1 and task 2 should ideally be removed, and all the data points in your sequence, the remaining task, should be shifted, correct? What we need here is that something which can store all your tasks in a sequential fashion. All right, perhaps remove the task one by one as you complete them. You should be able to access any particular task. All right, you should be able to know, let's say, I have, what is my 10th task for the day, etc., and so forth, right? So you need a data structure, okay, in this, which can sequentially store all your data, okay, as your task. You should be, of course, able to read. You should be able to say, hey, what is my 10th task? Okay, tell me what is my 10th task. All right. Or you can say, okay, what is my last task for the day? Something like that. Okay. You should be able to update your task. All right. If the details of the task changes, let's say the due date, let's say description, etc., and of course, you should be able to delete it, right? What we call this as CRUD, okay, in short. So ideally, a data structure should be able to store the data and should be able to help us with CRUD operations. What are CRUD operations? Create, read, update, and delete. All right. So we should be able to, okay, do these things in a good way, all right, in an efficient way. Okay, let's start looking at our very first data structure. You have already seen list, right? I'm assuming that you have worked with list already. Okay, essentially you store, all right, a data, okay, and I'm just making some data points as circles here, but it could be anything. It could be a string, it could be integers, it could be a mix of all of these things. But essentially you should be able to store your data points in a sequential order, all right, and you basically wrap it up in square brackets, right? This is what you've done before, all right? So in this case, let's say if I have 5 tasks to do, I have stored complete project task as the first element, code review as the second element, and so on and so forth, right? But hey, the positioning index in Python starts from what? 0, correct? So this is at my position 0, this is at my position 1, this is at my position 2, 3, 4, and so on and so forth, correct? I hope you're able to understand. Now, what I'm going to do is that I'm going to go to the Newton playground, okay, write some code for you. We should be able to first create a list. We should be able to access some elements. We should be able to do some modification, and we should be able to remove it, all right? And then we'll come back again, summarize all of these things, and move to the next data structures, all right? Sounds good? All right, so I am here on the Newton platform. Okay, what I did was basically I opened a new playground, okay, in Python. I hope you would have done it. And what I did is I basically created 4 variables, all right, with some dummy data, all right, for the task I have to do, right? Let's say if I have to create a list, okay, I would say tasks, okay, equals to task 1, task 2, task 3, task 4. Okay. I could actually add a task here directly also instead of creating a variable. So I could say, okay, dummy task, and this is also fine. All right. But for the sake of it, just to kind of save some time, I created these as variables. All right. Let me just quickly show and check if that if this list is created. So I have written print tasks. Okay, I'm gonna go and quickly run it, see if my all 4 tasks are running or not. All right, there are some print statements that I've added in the start. Let me just perhaps comment them so that it doesn't disturb our flow. Okay, let me just run it quickly. All right, so I have created a list which has essentially 4 tasks. All right, so creation is done. CRUD. All right, creation is done. I will now go to read. All right, by read, we should be able to read, all right, this list in different ways. All right, so the easiest way of reading a list is what? Run a for loop and read all the elements one by one. So I can just say for task in, let's say, the list tasks, okay, print the task. Okay, this should be, giving us, okay, the list of the task one by one. All right, let me just uh, put this print statement as a command, as a comment. All right, so as you can see, all these tasks are printed, all right, using this statement one by one. All right, so it basically iterated over each task, okay, one by one through the for loop, okay, and printed this. All right, let me just put this also in command and start with accessing, okay, some elements one by one. Let's say if I have to print my first task. All right, we have learned indexing in past. How can I do it? I can say task square bracket, and within square bracket I'm going to put what? I will be putting the index which I want to access. Since I want to access the first task here, I will be putting what? 0. Make sense? 0, because the positioning or the indexing in Python starts from 0. Let's quickly run it and check it. This should ideally be printing what? The task 1. And what is our task 1? Complete project report. So this should be printing, hopefully, if we are right, it should be printing complete project report. Let's quickly check. Yes, it says first task, complete project report, and we can move to the next one. In the next one, maybe give it a pause, all right, and try it by yourself, all right. As I am doing these exercises, I would genuinely suggest you that you pause the video once in between, try probably like, thinking in your head, uh, or maybe like code along with me, writing by yourself, then replay. If you're not able to understand, go over it again and try code along with me, all right. Now I have to extract the 8th task. Technically, I don't have the 8th task here, right? But let's try. Ideally, if I had my task 8, I would have been writing what? Tasks, whatever the element is there at positional index 7. All right, let's quickly run it. Let's see what it is it gives. Okay, it says, okay, there is some error. Okay, it says index error. That means the error is related to the index, and it says list index out of the range. It doesn't exist in the range, right? Makes sense, right? Let me put these statements as comment now and move to the next one. The next one says, hey, print the last task. All right, how can we access the last task? Technically, in this one, I have what? I have 4 tasks, so I can say task position what? 3, right? But hey, I think you would have learned negative indexing also. What will be the negative index for this task, which is the last task? -1. All right, so I will say tasks and -1. Let's quickly run it, check it. Woohoo, last task. Yes, last task. Feedback session with your manager, the scariest one, right? Shall we try slicing? What is slicing? Slicing is that I should be able to access a slice of my sequence. All right, let's perhaps try maybe accessing the first top 3 tasks, priority task. Since we are storing these tasks, okay, in an ordered fashion, all right, in an ordered fashion, I will be, I want to access the first 3 tasks, all right. How will I access it? I will say tasks, okay, and I want to access starting from the first task to the top 3 or the first 3 tasks, all right. So position 0, position 1, and position 2, all right. But the last position is not included. And since I want to access the first three position, I will say 0, 1, 2 is what I want to keep, but I will write the position index till what? 3. Okay. So I will say 0 to 3. Let's give it a try. Let's run it quickly. Woohoo, we have first three tasks. Interestingly, you can actually skip writing even 0 here, right? You can just run it, see what do you get. You should be able to get the same thing. Make sense? Now it says, give me the next three tasks for tomorrow. All right. We have very less tasks defined here. Perhaps we could have mentioned more, and I will make changes to this code. All right, to make things more interesting. But maybe let's try extracting the next three tasks. All right. Since we don't have next three tasks, once these tasks are done, we just have one. So we'll try just writing maybe, okay, give me all the tasks, okay, starting from index what? 3 up until end, because I know that, all the tasks are not there. Ideally, if there would have been more than this task, we should have mentioned 3 to what? 3, 4, 5. So 3, 4, 5 is what we want to extract, and the last position is not included. So you write 3 to 6, right? But let's just quickly run it. See, I'm gonna put this as a comment, run this. Woohoo! We've been able to extract the first task of the next day, right? Awesome. Now, I've done creation. I have been able to read. Okay, let me just quickly summarize it by going to the slides. Okay, so the way that you do, let's say, creation is as follows. You basically add all the tasks in the list. Okay, and maybe just print it. Here I have also, what I'm doing here is that I am also printing the length of this list. All right, so it essentially gives me the number of elements present in this list, right? Next, we saw how can we read some tasks. So if you have to access the first task, you will be mentioning 0. Okay. If you want to access the 8th task, you will say task 7. If you want to access the last task, you can do it using -1. First three tasks, 0 to 3. Next three tasks, 3 to 6. That makes sense, right? I'm going to use this example in the playground as well. Okay. For our remaining lecture. Okay. Now we will get to update. Okay. How should we updating it? And we'll discuss this in the next video. We are done with most of the operations on list. Okay. We have done C, create, R, read, U, update, and now we are left with D, delete, right? So in this case, specifically, we would have two things to do. Okay. We would actually want to delete a particular element by providing its value. Basically, what is the value stored at what is the value of the element which we want to delete? And sometimes we may want to actually delete using the positional index. Let's quickly check it out, both the cases. Okay. So I have this list with me. Okay. I'm going to first try doing what? Removing first occurrence by actually giving it a value. Okay. So let me say tasks dot remove. Remove is the method that you will use here. Let me say that I want to remove this particular value, which is say organize code repository. Okay. Let me quickly run this and show it to you. Okay. So what you see is that in the output, there is no mention of organize the code repository. Okay. If you want to, let's say, remove a particular element by its index, in this case, I want to remove the value at index 5, which is the sixth element, 0, 0, 1, 2, 3, 4, 5. That will be plans next week task. So ideally, if I remove this one, okay, if I say removed task equal to tasks dot, okay, pop is the one which we will use here. If you want to enter a particular index, I will say 5, and hey, I am saying that it should be popped and saved in a particular variable. Okay, here there's nothing to store, right? Because I am telling it that, okay, this is what you should actually remove. In this case, I'm providing it an element. We may also want to know, what has been removed. So I'm gonna actually print what specific element that has been removed, what was the value present there. Okay, so what it says is the plan's next week task is essentially what I am removing from here. Okay. Next up, what we will see quickly is another thing, which is list of list. It's a very simple, okay, a very simple concept. The idea here is that, hey, until now, I was just storing the description of the task, let's say complete project report, etc., etc. But now I may want to store some other things also, some other details as well. Let's say what is the priority, okay? What is the priority of a particular task? What is a due date, okay, of a particular task, right? So now every task has three things to be stored. So what I'm trying to do here is that I will actually create a list of three elements storing details, okay, let's say description, priority, and due date, okay, due date, okay, as details of one particular task in a list. And I can create multiple such lists of different tasks and create a list of list. Now what is happening here is that there is a list or which has some elements, okay, equivalent to number of tasks, okay, number of tasks, and every element is not an integer, a float, a string, or a boolean. Every element is also a list in itself. Okay, so list of list. Okay, you can compare it or think of it as a 2D matrix also. If you are someone from maths background, or if you've done some bit of matrix multiplication, all of that, you'd be able to understand. And don't worry if you're not able to understand. But yes, essentially you can think of it as a matrix. If you think of a list as one-dimensional list, or you can think of it as list of list, right? Now, if I want to, let's say, specifically, okay, want to extract the details of a particular task, okay, I could just say task details 0. This will give me what? It will give me all the details of the first task. But if, let's say, if I say task details 0, it will give me the details of the first task, and then I am mentioning another index, okay, in another square brackets 1. So it will go to the positional index of the first list, and what we have here is high. Okay, so this will essentially return high. Okay, are you able to understand? I'm not going to go into the details of the code. You can just check it and like perhaps try it at your end. But this is essentially what you can do if you have more elements to store in a list. Okay, there are, of course, better examples, better ways of storing this, but that basically will be done as we study the next data structure. Okay, so we have more than one details of any task, right? We have details, description, we have priority, and we have date. Life is good. You have created 5 lists storing all these data, okay? And you have created a list of lists to store all these 5 lists, correct? There is one problem though. The details, priority, and dates are sequenced in a particular order, right? So in case if you want to check the priority, if in case if you want to just get, okay, what is the priority of task 2, okay, you would have to remember that you have to go to index 1, okay, of any task to basically extract the priority. Now, dictionaries are better way to kind of work around with this kind of challenge, wherein what you do is you basically create key value pairs, okay, key value pairs. All right. Let me give you a quick demo. Okay. You can perhaps code along with me. So I had a list of lists stored as task details. What I have done here is I have created a dictionary. Dictionary is created with curly brackets with a key value pair. Okay. So here we have key as the description and the real description as the value. We have priority as the key and high as the value. Okay. This is a dictionary corresponding to one task. All right. How can this be helpful? If in case, if I want to check, okay, priority for this task, I will say task one, within square brackets, I will mention the key. Okay. I will mention the key over here and make it run. Okay. This will give me high. If I had to do the same thing using list of list, I would have to write task one. Okay. The name of the positional index where priority is saved. That's what? One. Okay. Let's run it quickly and see. Oops. Task one. Okay. It should not be task one. It should be tasks details. And then I say task one, which essentially would be 0, and so on and so forth. Okay. Okay. So as you can see the difference in here, okay, what do you think? Which one is a cleaner way of printing the priority of my task one? This one, of course, right? So what I can do is I can mention all of these, okay, all of these tasks as dictionary, and instead of creating a list of list, I can create a list of dictionaries, right? So this is again a list, still a list, but what I do here is that I will define each task details, okay, as a dictionary. Okay. So let me just try perhaps extracting details of second task. So I'll say tasks details, second task. So I will use index 1, and this would essentially give me my details of the first task. Okay. Okay. I can access a particular detail, for example, let's say date. Okay. So I'll say due date. Okay. And this will give me just the due date of my second task. Okay. I hope you're able to understand. Pause the video here. Probably attempt it from your end. Code along with me. Just pause, see if it works at your end, and then you can resume to follow along. All right. Okay. So next up, what we can also do is, instead of creating it as a list, how about I create a nested dictionary? What do I mean by that is that not just it's a list of dictionary, it's a dictionary of dictionary. All right. So I could also give a key like task one here, and the value I define here is a dictionary in itself. All right. So just to save some time, I have kind of written this code prior to this. Okay. So I defined a tasks. Okay. Let me call it tasks details. Okay. Just to remain the same. Okay, let me just stick to tasks. Okay. So tasks is a big dictionary wherein each element, okay, is also a dictionary with the key as task 1, task 2, task 3, task 4, etc. And the value also is a dictionary, and that dictionary contains the real details of that task, including description, priority, and due date. All right. Let's see a couple of interesting things here. Okay. So here are a couple of tryouts. You should be doing it along with me. Okay. Perhaps trying some other things as well. So let's start with actually just checking how many tasks are present in this. Okay. So I'll say len, okay, tasks. Let's see if it gives me an answer or not. Yes, it tells me that the number of tasks are 4. Let me print uh, these things. Okay. Sorry, stop printing these things so that we have a cleaner output. We will say number of tasks is this. Next up, we will print the details of the first task. How will you do that? Again, it's a nested dictionary this time. So you have a key. You don't have a positional index. You will say task, square brackets, and within square brackets, you will mention the task that you want to extract. You want to extract the first task, right? So you will just say simply what? Task 1. Let's see. Let's run and see if we get the answer or not. Yes, it gives me the details, all the details of the task as a dictionary, right? Each one is a dictionary, correct? Now I want to get, let's say, the priority of the second task. How do I get it? I will say tasks, okay? Which task do I want to extract? Task 2, right? So I'll say task 2 as the dictionary, okay? Now this part will give me the entire detail of the task 2, right? But I just want to extract what? The priority, right? So I will say, just give me the priority, okay? This is a nested indexing format, correct? Let's see what's the answer. Yes. So we've gotten the priority of the second task. That's what? Medium. Okay. Last couple of tryouts. Let's say you want to print the task 1 details. Okay. This is pretty simple. Oh, this is something that we have done already. Let's try this one. You want to print the details of task 5. Okay. Give it a try first by yourself. Okay. I'm going to do it here, but you can quickly pause and try coding along. Okay. I'm going to say tasks. Okay. And in this, I'll say task 5. Before I run this, you check it at your end. Okay. Pause it for 10 seconds. Okay. Seems like we have some error. Now, I would like you to think why this error is coming. Let's try reading the error alongside. Okay. It says it's a key error. Okay. Task 5 is a key error. And what is perhaps happening if we look at the error is that it was not able to find anything named task 5. Can you see that we have defined task 1? We have not, right? So this is what would happen if in case if the key that you try to access a particular value of, if it's not defined, it will give you a key error because that key doesn't exist, correct? So this was intentionally put in so that you can understand, and if you get an error, you can figure out that, hey, should I even check that, if I've defined this or not? All right, that happens pretty much a lot. Okay, cool. So we have all of these things. I'm going to comment out this part and move to the next bit. Now we should be checking how do I iterate over all the details one by one, right? Now, if you have to iterate anything, what do you use? You use a for loop, correct? I can use a simple for loop here. Let's say for task in task, let me just say for task in tasks, okay? Let's see what it prints. Interestingly, it is just giving me the names of the task, okay? I have not commented out one line, one statement. So let me just go up and quickly comment out one of these lines. Okay, here it is. Okay. For task in tasks, okay. Interestingly, it is just giving me the names. Why? Because if you actually run a for loop, that for loop runs on the keys of the dictionary, not the values. Okay. So if you want to access both keys and values, what you will have to write is task dot items. Okay. Now let's try running it again. Okay. Now can you see that every time it is returning me task 1, which is the key, and the value. Okay. I can separate it as well. So I can say for task comma key. Okay. Now this time basically, not task and key. I would say task key, task value. And let me print the same. So task key comma task value. Okay. Now let me try running it. Woohoo. So now we have been able to print both of these things, and this way you can extract keys, you can extract both key value pairs, you can just extract values, and so on and so forth. All right. I hope you would be able to iterate through all the data if in case required from a dictionary. Okay. Just to summarize the dictionaries part, okay, until now we have learned 2 data structures. Okay, we have learned lists and we have learned dictionary. Okay, when is list helpful? List essentially is nothing but a sequence of ordered elements. All right, it's a sequence of elements that you store in a particular sequence, and those elements, I'm sorry, can be accessed using positional indexes. So if in case if I want to access the first element, which positional index will I use? 0. If I want to extract the third element, let's say, which one will I use? Which positional index will I use? 2, correct? 0, 1, 2. That will give me the third element. If I want to access the last element, okay, which positional index will I use? -1, correct? Now, dictionary actually helps us in case if we want to use something else, but not positional index, okay? That means an integer as a key to access something, right? So instead of, let's say, using those boring numbers 0, 1, 2, 3, 4, and I wouldn't remember it, I can use some interesting fancy uh, words, values, even integers, anything to be used as a key of a dictionary. Now, there are some possible only few valid keys in a dictionary. Let's go and check them out quickly. Okay. What we see here is that any valid key, okay, any valid key for a dictionary should be immutable. Okay. It should be immutable. That means it should not be changeable. Okay. What do we mean by that? Let's try to understand with an example. Let's say if I have a variable x, okay, and I am storing 2 in this, okay, what is happening in the backside is that an object of type integer, okay, is getting created, okay, and it is storing a value 2, okay, and that starts pointing to the variable x. Now, when I say x equals to 3, okay, do you think that this 2 will get replaced by 3? No, that does not happen in Python. Okay. What happens here is that another int object, okay, will be created having value 3, and this will start pointing to x, okay, and this linkage will get deleted. The learning from this example is that, okay, an integer object is immutable, right? That means you can't change the value of it. If you want to if you want to replace it, what you'll have to do is you'll have to create a new object. Okay. Are lists, dictionaries mutable or immutable? Think about it. Maybe just take 10 seconds to think about it. What do you think lists and dictionaries are? Mutable or immutable? Remember, we actually changed some values of a list or a dictionary, right? We saw CRUD operation, CRUD, right? In the U operation, update operation, we were able to change the elements of a list, right? We can similarly change the elements of a dictionary also, right? So these are mutable. All the primitive data types like integer, float, string, bool, okay, are immutable. Okay, why? Because if you want to change it, you'll have to create another object. The data structures that we have learned until now, lists, dictionary, are mutable. And what we say in the case of valid keys of a dictionary, you can just use the ones which are immutable. So if you want to use integer for a key, go ahead. If you want to use a string, we have been doing that. If you want to use a Boolean value, true or false, yes, please make sure, no problem. Okay. What you cannot use is list because it is mutable. Sorry. You cannot use dictionary. Again, it is mutable. You can make a lot of changes. We will see two more data structures, tuples and sets, and we will see that you can use tuples, okay, because they are immutable, and you cannot use sets because they're mutable. Okay, take a little bit of time to just absorb this. Okay, if you're not able to understand, you do not have to worry. Okay, all you can remember here is that the valid keys of a dictionaries are integer, float, strings, and boolean. Why? Because you cannot change them. Okay, if anything is changeable, that is not a valid key, okay, for a dictionary. All right. After this, we will be starting with another data structure called sets, and after that, we'll learn tuples. So I'll see you just in the other module. Hi everyone again. I hope you're enjoying the course on Python for data analytics. Um, So we have learned lists, we have learned dictionaries. Okay, both of them have their own strengths. Okay, you will actually get to know that accessing any details, okay, through a key is not a very heavy task. All right, when you learn data structures and algorithms in detail, all right, you'll get to know that accessing any value using key, all right, is pretty fast, actually much faster, okay, than list. All right, so I'll suggest that you start using dictionaries for a lot of things. All right, when all you have to remember is just the sequence, all right, and nothing else, right, you can then use simply a list. Now in this section we will go through another interesting, super interesting data structure called sets. Okay, you might have learned sets in mathematics also. Okay, but let's start from scratch. Okay, now let's say, if in case if I want to store some elements, 1 2 3, let's say, okay, and I store it in a list, okay, calling it R. Okay, now I can do something like R dot append, okay, or R dot insert to insert another element. Correct, I can do that. Now that's not a problem. Let's say, if in case if I end up, okay, adding one more element here, it will be added, and there is no one stopping me from adding a repeated element over here, so I can add a 2 again. Correct. Now why is that a problem? It's technically not a problem if repeated values are allowed. But let's imagine a scenario, okay? You are on the internet scrolling something, and you want to download a file, okay? When you download a file, okay, uh, if in case any other file of the same name exists in that folder, okay, your OS gives you a notification, okay? Do you want to replace it, okay, or do you want to create a new file? And when you say create a new file, it will actually add some suffix like 1 2 3 in the end, and it ensures that all the files in a folder are of different names, right? Which means you can't have two files in your folder with same names. Correct. Now, in such cases, what you're trying to do here is you're trying to create a set. That means no repeated value is allowed. If in case, if you want to use a data structure wherein any repeated value should not be allowed, you should not be using a list. You should be using a set. Okay. Set does not allow repeated value. And that's it. This is what a set is. Okay. In a very simple form. Okay, it will have all the unique elements. So if you've defined a set, you can be rest assured that everything will it will have all different elements. Now the interesting part which comes in sets is, one, how do you define it? Okay, we'll just see in a while. It looks something of a mix of list and dictionaries. So you don't use square brackets, instead what you use is curly brackets. All right, but hey, don't we use curly brackets to define dictionaries? Yes, but in dictionaries, what we have is a key value pair. Whereas in sets, we just have essentially values. All right. So, what is the way to kind of define a set without a key value pair? You can just simply use curly brackets and put elements with comma separation, just like how you do it in list. We'll just see in a while when we actually go to understandings the sets a little bit more. There are couple of common operations that you can use on sets, following names as union, intersection, difference, okay, and symmetric difference just in a while. Now to motivate this part, I'm going to use another case study. Now that you've learned a little bit of Python, you've started applying for jobs, okay, and you may have some other skill sets also. In this case, I am saying that you know design as well, okay. So here, okay, as an HR or a talent acquisition manager, I am storing a set of two candidatures. Okay, why set? Because I wouldn't want two resumes, okay, two same resumes of same people to be like added to my list. All right, I would want all the candidates application to be unique. All right, so I have applicants, okay, who have applied for a tech role. I have applicants who have applied for design roles. Okay, so here is basically two sets. Okay, one is for tech, one is for design, and I have, okay, jotted them down as sets. Okay, so let's just go and quickly see, okay, what interesting operations we can do on it. So I'll go to the Newton playground, okay, define these sets. Just to save some time, I have defined them before, and I will try to get answers for the following. First, try out, list everyone, every person who have applied regardless of their roles. So what I'm saying is that, hey, I don't care about whether they've applied for tech. I don't care about whether they've applied for design or anything for that matter. All I'm saying is that, okay, give me basically list of people who have applied at Newton School, let's say, for something. Okay. So I will say applicants tech or applicants design. Now, what do I mean by this? I am saying, okay, just give me applicants who applied for tech or for design. Okay. In order to visualize it a little bit better, okay, I will just go here and try to explain it using something called as Venn diagram. Let's say this one circle, okay, basically represents all the people who have applied for tech. And this set, this other one, actually represents those who have applied for design. Okay, so A is tech, B is design. Okay, now I am saying that, hey, give me all the applicants who applied for either tech or design. Do I mean that I am basically looking for this entire set, right? A or B. Okay, so A or B is typically represented with this line, and it is also called as a union operation. You're uniting both the things. Okay, union of two things, uniting two things. Okay, in case, let's say, if I want to do something else, say maybe if I want to get those people who applied for design. Okay, so it will be simply what? This set B. But the interesting question is, I want to look for people who have only applied for design. Okay, only applied for design. How do I get it? Let's first try to understand, what do I want to get here. Can I say that I want to get this part? Okay, how do I get this? Can I subtract? Can I take the entire B? Okay, can I take the entire B? Okay, oops, and remove this part, the intersecting part. Okay, so should I first find the intersection of these two? What is intersection? Those who have applied for both the roles. Okay, so for intersection, what we use typically is, okay, this is a little bit messy, so let me just clean this up a little bit. Okay, let me do intersection first. Okay, so here is what you want to do. You want to get the intersection. Okay, this part first. Okay, so both design and tech. Okay, so for this, what you will do is, you will say A and B. Okay, those who have applied for tech and applied for basically design as well. Okay, now if in case, if I want to calculate, okay, if I want to get those applicants who have applied only for design, right, if this is what I am interested in. Okay, so I will do B minus intersection of A and B, B minus intersection of A and B. Correct? Correct? Or I could also do union of A and B minus, okay, this part. That's the same thing. So we'll try to understand sets using another case called job applications. Okay, so let's say you have learned something and you've started applying. Okay, and you're applying at Newton School. You decided to apply for a tech role, and you applied for a design role as well. Okay, now ideally, what I would like here is that any applicant's resume is just present once. Okay, we wouldn't like two resumes for one single applicant to be present in the set, right? So you will not use a list here, you will use a set. So I've defined two sets here: applications tech, Alice, Bob, Charlie, Diana; applications design, Charlie, Eve, Frank, Diana. Okay, that's fine. And I have defined them using curly brackets. Okay. Now I want to answer a couple of questions related to these sets. Okay, so we'll see that. Uh, Let me just remove this part and explain from scratch. So in mathematics, if you would have learned, you define one set using a circle, okay, in Venn diagram. Okay, so I have defined a circle, let's say A, another circle, let's say B. And here, A is defining all the people who applied for a tech role, and B is defining all the people who have applied for design role. Okay. To start with, if I want to say, okay, give me a list of people who have applied for any role. I don't care about what role they have applied. I just want to know the details of all the people. Okay. Which means essentially the set that you want to get details of is this entire part, right? So you are uniting these two sets. Okay. You are taking a union, or you're uniting these sets. Okay. The way you define union, okay, is through a vertical line. Okay. So when I actually, say print applicants tech, vertical line applicants design, ideally it should be giving me a union of both. And since it's a set, okay, in the output, any person, let's say Charlie, if they have applied twice, their name will essentially only come once. Let's run it and quickly check the results. Okay. Can you see that every value or every applicant's name is only appearing once? Okay. Next question is that you have to define a list of people who have applied for both the roles. That means you have applied for both tech and design. Let's see how will we do this. Okay. So I will again define set A as people who have applied for tech role. I will define B as set of people who have applied for design role. Okay. In this case specifically, what you want, basically a list of people who have applied for both the roles. Okay. So what you are trying to take here is something called as intersection. What? Intersection, right? And the way we define intersection is as follows. You will use an ampersand sign. What? You will use an ampersand sign. Okay. So I'm going to say print, okay, applicants tech, okay, and applicants design. And ideally I should be getting what? Since Charlie has applied for both the roles and Dinah has also applied for both the roles, I should be getting Charlie and Dinah in the output. Okay. So Charlie and Dinah. Okay. I hope you're able to understand. Okay. Try some interesting things to do by yourself. Okay. Make interesting use cases. Next one is something that, I would want to probably you to think a little bit before you try it out. Okay. Otherwise I'll explain. Okay. Next question is list of people who are interested only in design. Okay. Only in design. Okay. So I will just again define these sets A and B. Okay. And notice that what you're looking for is those people who have only applied for design. Okay. Can I say that this is nothing but essentially B minus intersection? B minus intersection. Correct? So let's perhaps try it out. Okay. I'm going to say print. Okay. You take B, which is what? Applicants design. And what you're trying to do is you're trying to subtract, okay, those who have not applied for, or those who have applied for both tech roles and design roles. Okay. So I can simply copy this part. Okay. I can simply copy this part. Okay. Let's give it a try. Okay. So it says that Eve and Frank are those people who have only applied for design role, because yes, Charlie and Dinah they have also applied for tech role. Okay. Now the next one is saying list of people. Give me the list of people who are interested in only design or only in tech but not both. Okay, only in design or only in tech but not both. Let's try to maybe visualize this. Okay, so I have said A representing tech, B representing design. Now this time I'm looking for people who have either applied for tech only or who have applied for design only. Correct? So in this case, I can take a union of both and subtract the intersection. So I can take the union of both and subtract the intersection right? Let's give it a try. I will say print. Okay. I will take this part, which is essentially union. Okay. Put it in bracket and then I will say subtract. Okay. This part, which is this one. Okay. Let me try running it. And yes, this basically gives me list of people who have applied either for tech role only or people who have applied for design only, but not both. Dinah and Charlie, they have applied for both the roles and hence Dinah and Charlie's name is not present here. Okay. One last thing that you can do here, very interesting stuff, is that let's see what if you just simply, okay, do applicants tech minus applicants design. Okay, applicants tech minus applicant design. Okay, let's see and try to guess what do we get in the output. Okay, what we are getting here is Alice and Bob. Now think about it, why you are getting Alice and Bob here. Alice and Bob are the ones who have applied for tech, okay, but haven't applied for the design. Just think about it. Which one of these are actually similar to this one? Can I say that this one, uh, actually the reverse of it would be similar, right? So I can, if I would have done, let's say, design, okay, minus tech, I would have gotten this answer. Let's give it a try. Eve and Frank here, Eve and Frank here. Okay. So instead of calculating an intersection, you can just simply say that, hey, okay, just perhaps, remove tech. Okay. Just give me all the people who have applied for design minus people who have applied for tech. I don't even need to, calculate their intersection. Okay. Now, this is not symmetric difference yet, right? What you tried replicating is you are just saying that, hey, give me people or give me the list of applicants who have applied for design, okay, but not tech. Similarly, you could also do the reverse. You could say applicants, okay, applicants tech minus applicants design, okay. In this one, this will give you only design. This one will give you only tech. Now, if you do this operation, okay, wherein you say applicants tech, symmetric difference, which is defined by what? A caret. Okay. You'll get a very interesting answer. Okay. What you'll get here is as follows. You will get Frank, Bob, Alice, and Eve. Okay. That means you are not getting those people who have applied for both the roles. Okay. So symmetric difference essentially is giving you either tech or design, but not both. Okay. But not both. Okay. I hope you're clear with sets now. Okay. As we said, there are three, okay, operations that you can do. Union. Okay. Union will give you a union of both the things. You are uniting the sets. Intersection will give you what is common between both. Okay. Difference will give you, uh, if you do a minus b, it will give you all the values in a which are not in b. Okay. If you do b minus a, it will give you all the values in b which are not present in a. And if you say a symmetric difference, which is basically represented using caret. Okay. If you say a symmetric difference b, it will give you either A or B, but not both. Okay. So this was sets. Okay. Very helpful. Okay. In terms of, creating a non-repeating list of elements. Okay. I'm saying list of elements, but you get the idea, collection of elements or whatever. And yes, you can apply very interesting operations on it. Okay. We will go through one more interesting data structure, and the last data structure we'll be talking about, and this is called tuples. Okay. I will take another interesting use case of saving flight records to make you understand this. So what you have to do here is that you have to save the following details. You have to save passenger names, flight number, departure city, destination city, seat number, meal preference, and so on and so forth. Okay. You can store all of this in a list, correct? You can store this in a list, you can store it in a dictionary. But for now, for the sake of it, let's just try to store it in a list, okay, to start with. Okay. So I have created these list, okay, storing all of these details, and I created a list of list. That's something that we have learned. Okay. We call it 2D list as well. Now, the interesting part, what I can do here is that, let's say a user comes to me, okay, and ask me that, hey, instead of having a veg meal, okay, I want to have a non-veg meal. Okay. The first user, uh, or the first traveler, Alice, they basically want to have a veg meal. Okay. I can do that. I can say tickets, okay, first user, which is Alice, 0, and I will try to extract, okay, its last element, which is their meal preference, and try to make it, let's say, non-veg. I'll try to make it as non-veg. Okay. Would this be possible? Yes. Lists are mutable. Okay. So I should be able to make the changes. Let's give it a quick try. Let's print it quickly and see. Yes, I have been able to change Alice meal preference to non-veg. Okay. Alice's meal preference to non-veg. Let me just comment this out so that you don't get a lot of things on the output. Okay. So this is fine. But hey, just the way I have been able to change their meal preference, Alice's meal preference, I can change anything, right? I can change Alice's name also. I can change Alice's ticket number also. Tell me, would you actually prefer that any detail is actually changeable? No, perhaps, right? So instead of using list, typically what we do is we actually store the data in what we call as tuples, okay? And the only difference in the way we define a list or tuples is that instead of using a square bracket, what you use is a round bracket, okay? So now I will try to change this thing again and let's see what happens. But just to kind of show, the first element is now a tuple and the second element is now a list. I will try to make the same changes for my second element as well. Okay. So I'll try to change their preference to veg. Okay. This is the second element. So I'll write it. Let's quickly see what happens. Okay. It says tuple object does not support item assignment, which means you can't change any element present in a tuple. Okay. Whereas, is it possible for a list? Let's check it. Okay. Let's run it for the second one. Yes, I'm able to make the changes. Correct. So tuples won't allow you to make the changes. So if you want to define a collection, a sequence of some elements where you don't allow changes, okay, you should be using what? You should be using a tuple. Okay. So let's negate this part and try to understand what is the right way I should have defined this. Okay. I should have created a dictionary wherein the things that I do not want to change, for example, the name and let's say the flight code, okay, I can define it as a tuple. And again, this is a key. You should be using something which is immutable as a valid key for a dictionary. So you can just define it as a key, and the other things can be defined as a dictionary. So seed, meal, etc., etc. All right. So in this case, I can say, hey, I access the booking dictionary, okay, and I try to access, let's say, Alice, okay, Alice's data. I will define it as the key. And here I would say, hey, I want to change the meal to non-veg. Non-veg. Woohoo. Let's see if this permits us to make the changes. I will just print the dictionary again and see the results. Yes, can we see that the meal options for Alice is changed, but other things remain same? You can't, of course, it's a tuple, so you can't change it. We can even try changing it. It won't get changed. Okay. And then other things remain the same. All right. So this was tuples. Okay. In case if I just have to explain it in a very short go, okay. Tuples are something which you can't change. Okay. Tuples are immutable. Okay. And if you want to store any sequence of data which you do not want to change, you should be saving it in a tuple. And if you want it to be changeable, you should be storing it in a list, right? And typically what we do is we use a mix of dictionary, list and tuples to store our data depending on what use case is. Okay. This was Python in data structures, and I will see you in the next module.